Remember how I told you about how B.F. Skinner made the pigeons become superstitious? The pigeons developed rituals to affect the outcomes of random events. Well, science shows us that there really are factors that affect the probability of events. But as you probably guessed, they're not rituals. The first factor that affects the probability of an event is whether the events are independent or dependent. Independent events are mutually exclusive events, in which the occurrence of one event does not influence the probability of other events occurring. For instance, washing your car does not cause it to rain, nor does dancing in a circle, planning a golf foursome, or mumbling incantations to the clouds. Betting on red because it's lucky, or betting on black because you always bet on black, does not influence the outcome of the roulette wheel. In the long run, you will always lose more than you win. These are independent events. Playing the same numbers in the lottery every time actually does increase your chances of winning, but not because those numbers are your daughter's birth date and therefore lucky. And your chances do not improve enough that it is a financially wise idea to play the lottery. The prime example of the misunderstanding of the nature of probability and randomness is called the gambler's fallacy. The gambler, after a string of losses, does not want to walk away from the table because, since the odds have been against him for so long, his luck is bound to change. He's due for a win. The chain-smoking, glassy-eyed slot machine player doesn't want to leave the machine because what if she does and the next person sits down at her machine and hits the jackpot? That was her jackpot, and if she'd stayed just one more round, she would have won it. The gambler's fallacy is a failure to grasp that all of these events, every roll of the dice, every turn of the cards, every pull of the slot machine handle, are independent of each other, so their occurrence does not influence the probability of the next roll. Probability only works in the long run. Of course, the best definition of superstition comes from musician Stevie Wonder. When you believe in things that you don't understand, and you suffer. The truth is that, over the long term, there will be more wins than losses for the house. You want to make money at a casino? Own a casino. Dependent events are events that we can control. Dependent events occur when the probability of one event is affected by other events. Whether you pass an exam depends on how much you study, or at least the probability increases. Your likelihood of dying in a car accident is dependent on whether you drink and drive, wear a seatbelt or not, or use your cell phone when you should be paying attention to the traffic around you. Want to reduce your probability of being in a car crash? Hang up and drive. Another factor that affects the probability of an event is whether there is replacement. Probability with replacement is calculated after any previously selected items are replaced back into the population. Choose a card, look at it, and then return it to the deck. That is probability with replacement. What is the probability that I can select your card at random? 1 in 52. Actually, those are odds. But if you keep the card, then what is the probability that I can select your card from the deck at random? 0. Or maybe 1 if I look through all the other cards and determine which one is missing. Probability without replacement is when the previously selected items are not replaced into the population. If you pick one card and do not replace it, the probability or odds for selecting a second card drop from 1 in 52 to 1 in 51. For example, we're having a raffle. Everybody gets a ticket to win a door prize. We put all of the tickets into a hopper and spin it around to randomize the tickets. Then we draw raffle tickets, read the winning number, and set each one aside. Is that sampling with replacement or without replacement? That is sampling without replacement. Now, in statistics class, we assume that events are independent and sampled with replacement. Now, why is that? The assumption of independence is part of sampling. If the events are dependent, such as we're doing a before and after study, so that your after score depends on your before score, then we're using a repeated measures design. No problem, but we need to know whether that assumption of independence of measurements has been violated or not. Now, the assumption of replacement is because in the real world, you get returned to the population after you have been sampled. Have you ever taken a poll or answered a survey before? Probably yes. Have you ever taken another survey after that? Yes? Aren't you glad that the first poll was not done without replacement? You would have been removed from the population after that poll. Not good. So we assume that events are independent and sampled with replacement.